So our last presentation is on tools for managing ontology quality, and that's from Karen Colesman from Ostis.
Thank you. Can you all hear me?
Yes, we can, and we can see your slides.
Okay.
Go right ahead.
Cool. Yes, I work on tools that help us develop our ontology and maintain our qualities. So I'm going to jump right in with an example. Hello. Slide. So these are two versions of the same file. We have a pump setting here, which I selected in both of them. So we have a label here, we have a definition. And on the bottom here, we have some relationships between the pump setting and other entities. Now I've introduced some differences to the file on the right-hand side. Just take a minute and try to see if you can spot them. Okay, here's one. I've replaced the and with the or. There are two more differences. Well, if you didn't find them, I know why, because you cannot see them in the screenshots. So let's take a different look at the file. Let's have a look at the Turtle source code. So I opened the file in a common Diff tool that is used by programmers. I used meld, so can you spot another difference now? Well, here it is. We have a trailing white space here. So that won't display in a graphical tool. So this is a style guide violation. So this white space should not be there, but it's extremely hard to find. Also, we have all these meaningless differences here, lots of extra added blank lines and stuff. That's because the Turtle format is not strict. And if you save the same file with a different tool, it might look different, although it contains the same data. So if I look at it with my nice merge tool that has a button to step through the differences, I have to step through tons and tons of meaningless white space until I actually hit this section here that I'm interested in. In addition to that problem, we have lots of files. So I did a little bit of statistics on our current repositories. So we have over 9,000 different entities just at recommendation level, and more than 200 files. And our data structure looks like this. For example, we have our pumping file, which is the example that I'm using throughout this presentation. We have lots of other domains like calibration, for example. And then this is the September 2020 release and recommendation level. And this is one of our domain ontologies. In addition to the recommendation level, which is the mature level, we also have candidate recommendations that are earmarked to make it into the next release. And then we have working drafts that are not mature yet. And with every release, we copy over the files and then start working on them. So all the files are always available. So now this folder has been copied into a 12 folder for the upcoming winter release. So again, even more files. So we need to manage our file change somehow and find our bugs. We want to comply to our style guide. We need to do some technical file setup, which I will explain in a bit. And this is just too much to do manually. So enter our Developer Operations Tools. All the tools can be run either manually on your own computer, or they can be run in an automated fashion. And I'll show you how that works too. So to recapitulate, our Turtle format is not strict. So we have all these meaningless differences. So in order to solve that problem, we have a normalizer tool. So once I run part of the normalizer. It looks like this, which is very neat. Now we only have the differences that we're interested in. This big block here, which you can't really see because we need to scroll to the right, that's our AND and OR change. Here we have our white space, and this one has another white space change in it that's also off screen. You'll see that one later. Yeah, so I scroll to the right a bit, so now we can see our AND and OR change, which here it says union of, and over there it says intersection of. Oops. And our normalizer tool is run automatically with every Git commit as we work on it. So Git is our versioning control system. So we check it into the system, and before it actually gets into the system, the normalizer gets run automatically. So the files are always normalized before they hit the AFO. So going through all this manually and trying to spot those bugs manually, of course, is not feasible. So enter the Styleguide checker, which was originally developed to figure out if we have any Styleguide violations, but has become more powerful over time. And it can be configured via a JSON file. And one of the things we have in our configuration is a regular expression check that we have defined to find our trailing white space. And because it's regular expressions, you can pretty much define anything you like to check for. So the first line of this is the line we're interested right now, the first line. So it says error type is a trailing white space. Then it gives the complete file name. I've abbreviated a bit to make it fit the screen, but basically this is what it looks like. Then we get the IRI. And we get the preferred labels, so to make it human readable, which entity it is. And there's no additional information needed right now because we can already say, okay, trailing white space and no additional information, so it must be on the label itself. Our second white space problem is actually that I introduced an additional white space between the full stop and the allotrope source notation. And our style guide says when we do a definition, it ends with full stop, one white space, and then the definition source attribution in square brackets. And if you add an additional white space, which is very easy to do and very hard to see even while you're editing, it complains. And we also keep a list of allowed definition sources. So once I fix the additional white space, I will get a different error that, well, not for this entity because allotrope is obviously allowed, but if I would put something in there where it would be a copyright violation to use the definition, then it would flag this up. This is what our current automation looks like. So as I said before, we use Git as our version control system, and GitLab.com is a nice front end for this version control system that comes with additional tooling and allows us to run automated checks. Let's concentrate on this bit right now. So we have our Styleguide checker running here 4 times because we have 4 different configurations for it, depending on which part of the AFO we are checking. So running it there saves us time because when you do a change, you don't have to run it on your own computer and wait for it to finish. You can just push it up to GitLab and continue working on something else while the pipeline finishes. It also ensures that the checks are being run, so you cannot forget to run a check. And it helps the ontologists to focus on developing content rather than focusing on what was that command again that I have to run and where's the tool. You don't have to worry about that. You just develop and then grab your report of the pipeline. So this is the bottom end of an actual pipeline run of our Styleguide checker. So we have a summary on the bottom. So in case it's just a few errors, you won't need to download. You can also download the full report, but sometimes you don't need it, so you can get a summary. It saves us time. And now we have an actual source violation here. This is sort of a placeholder we're using for new terms when we don't have a definition yet. So it has a 0 in here, and 0 is of course not a valid source attribution. So it complains here and says legal should vet this. So where are we in our package of tools? We have looked at the normalizer to minimize merge conflicts, to get rid of meaningless change, to make it easier to see what the actual change is on the source code. We have our Styleguide checker, which was originally developed to test for Styleguide conformity, but it's flexible and can be configured to your needs. We also have a duplicates report. What the duplicates report does, it grabs all the labels and definitions and then checks if the same entity has 2 different labels or 2 different definitions. This can happen when you have a lot of files and maybe you gave it a label in 2 different files and you wouldn't see it across the files. So this is really helpful for that. We also have a spell checker, which uses the Linux spell checker as a backend. We are developing on Microsoft Windows at Ostus, but so we can't run it on our own machines. But since we're running it on GitLab CI, which is where we are using a Linux environment, we can get the benefit of this guy as well. All our other tools are cross-platform because it's all Java or Python based. So any system that has support for Java or Python can run the tools. Another tool we have, Java-based tool, is the merger tool, which can be used to merge lots of files together into one file, and it can also run an inferencer. Finally, we have the release report. It sends off a Sparkle query to fetch information about our ontology across the files. So we get a spreadsheet with all the labels and definitions and superclasses. But since this is based on a Sparkle query, you can write your own queries and basically get any spreadsheet you like. Technically, it's a tab-separated values file. Okay, let's move on to the next section, which is catalog setup and verification. Now, as I said before, we have a lot of files. So we have our pumping TTL file, which we looked at. It sits in our domain folder. And this file imports AFO. Everything in orange here is part of the core AFO. So we have a taxonomy here, or AFO. We have a bunch of other stuff. Then the AFO again imports a perspective, which is the perspective organization, which in turn then, along with the AFT, imports some external ontologies, like the BAFO that Amnon just presented, and SCOS, which is used for annotations like pref label and so forth. It defines those, what a label is, what a definition is. So how do we find which file imports which file? So if I would take the pumping file and try to open it in the Protégé graphical tool to look at it, Protégé will then say, well, I am importing the AFO, please give me where the file is, and then I have to find it in my file system, then I have to find this in my file system and that and everything else in my file system the first time I open the file, which is of course not a nice way to spend your day. And once you have collected all this, Protégé then writes it into an XML format. So the next time you open it, you won't have to do it all over again. So we're actually leveraging the same file format to then manage our files in our tools. So both our third-party tool here and our own tools use an identical file format. The XML files are grouped into the entries in the XML files, which can map our ontology names to our actual files, can be grouped. So there's a group tag. So we're actually leveraging this group tag to define different check levels. So, for example, I can run the Styleguide checker just on the recommendation and candidate recommendation terms to see, are they all green? Or I can say, okay, now I want to add our working drafts, and maybe that's not green, but it's not critical because it's just the working draft. So they have less importance. So it's more important to get this job green than it is to get that job green. So what our tools can do for the XML files, they can generate the catalogs, they can read the catalogs, and they can also validate. And this is actually the first step in our pipeline. We check whether the catalogs are up to date to ensure that everything's okay. Sometimes you add a file and you forget to run the generator, and then it reads the catalog files to create our setup for the pipeline. So we have three tools for the catalogs. One is the catalog reader. It reads the files and prints the output to a TSV file. This is so tools can then just read them from a flat file and don't need to parse all the catalogs every time they want to see which group a file it is in, and so on and so forth. Then we have the catalog generator, which allows us to automatically generate the catalogs whenever we add a file or change a file name or move something. And then we have our modules verifier, which then checks the catalog files against the shadow files to see if they still match. For example, I could also maybe change the name of an ontology and keep it in the same file. The modules verifier would notice that and say, hey, you haven't generated the catalogs. Please go ahead and do so. Our next section of tools are some productivity tools. I'm not personally involved with those, so I can't tell you much about them. I just wanted to mention them so you know that they're available, and they revolve around shackle shapes. So one tool is an editor, so you can easily edit shackle shapes in Eclipse environment. And the other one is the shackle validator. You can define shackle shapes that define what the structure of your ontology or part of your ontology should look like. And then you can validate that. So you can validate the ADF data descriptor or validate whether our AFO complies with our data model. Let's move on to the other tools we have, which feeds into what I've started working on right now, which is to automate pushing our release to various sites. So the general idea is we just push a button in the GitLab CI and the current AFO is published. That's the long-term goal. And we want to publish to different sites. We want to publish zip files to the JFrog and to Client Connect. We want to publish our ontology suite to our own server. And we also want to publish to external services to raise the visibility of the AFO. And at the moment, we're looking at Ontobbe, BioPortal, and OLS. So what do we need to do to accomplish that? First thing we need to do, we need to think about handling file formats. Internally, for our development, we use the Turtle file format, which is the source code you saw earlier. And it's a human-readable format, so it's really good to use for the actual development. But there's another format that's faster for computers, and that's the RDF XML format. So it would be good if we could convert from Turtle to RDF XML in a reliable manner. And I hope we will get up some speed out of this for our own sites, which will improve the usability of our site, because the lookup can take a bit until it finishes right now. And also external sites prefer the RDF XML format, so it would help with visibility on external sites if we could simply provide an artifact to them as part of our release automation. And the requirements I've identified as first, obviously we need to automate the conversion from Turtle format to RDF, and we're going to look at available tools and leverage external tools for that, so we don't have to reinvent the wheel. But what we want to do is to verify the correctness of the conversion to make sure that the files are still semantically equivalent after the conversion. So here's our pumping file again. In the two versions, only on the right side, I've now saved it as an RDF file. And as you can see, you can't see anything whether it's equivalent or not, because the format is just so completely different. So enter the Semantic Diff tool, which is a brand new tool that I've just finished developing. And what this tool does is it takes both files, looks at the differences, and writes just the differences to Turtle files. So we have a 1_pumping TTL and a 2_pumping TTL. And the right-hand side only contains the triples that were not in the first file, and the left-hand side contains only the triples that were not present in the second file. And we again have our trailing whitespace here. We have a diff definition with the double whitespace in the back, and this is our restriction. And actually what you see on screen here now is the complete file. There's nothing else in this file. And for reading and writing the files and loading the files, we use the Apache Jena API, so we can handle any file format that the Apache Jena API can handle. So scroll to the right, and we have this restriction here with the intersection, and here is our extra blank space in the definition. So what could we theoretically use this tool for? It's brand new, so we haven't really put it through its paces yet. The original goal was to validate the file conversion, but it also gives you a compact view of the changes, and it might be theoretically be helpful for writing change logs to get this really compact it down to something where you don't have to scroll a lot, and it might also help us finding accidental deletions, because we still have a trailing whitespace here, but if we didn't have that, we would only have this one line in this file. So we said, okay, why is this line not there? Oops. So to recapitulate, we have tools for normalizing our files and to verify against our Styleguide. We have tools for technical setups for the catalogs and for defining our check levels. We have productivity tools for Shackle. And we have other tools. So apart from the semantic diff that I just presented, we have a tool that compares a current repository against the published artifact on JFrog Artifactory. As one of our guides is, for example, as we now start working on the December release, any files in the September release should not be touched anymore. So if somebody accidentally touches it, this tool will flag it up. Then we have a collection of miscellaneous Python tools that do small but useful jobs. One of them is to convert JSON to tab separated value. For example, when I run a Sparkle query for a release report, I get a JSON file back that's not human readable. So we have a converter. And there's also a tool to print the first few lines of a file. Now we might ask the questions, why did I write that? Well, to return to our pipeline run, here's our summary. That's what the tool is for. So what would I like to do in the future with the tools? I would like to do more maintenance on our pipelines. Sometimes our requirements change, so the tools need to adapt. And since it's software development, there are always bugs. So as you can see on the top, there's a screenshot from a pipeline run back in 2018. And I've had a recent pipeline run on the bottom. And as you can see, we have lots more checks now. Whoops, let me go back. We have lots more checks now than we used to have, but also some checks that used to be green are now not green anymore, like the Styleguide check here, or the merge check here. And the reason why this fails might be a change requirement, it might be a bug in the tool, or it might be an actual data bug in the AFO. So to recapitulate my future plans are to continue working on the release automation, to refine and adapt the tools to new requirements, to continue cleaning up the AFO data for Styleguide conformity, and to do bug fixes. There are always bug fixes. And finally, this is where we get it. We have a wiki on GitLab. And in this wiki, we have instructions, we have examples on how to use the tools. You can download the tools from there, and you can also access the source code from there. All our tools are open source. The spell checker is under a general public license because it's based on the Linux spell checker. Everything else is available under the Apache license. And if you navigate on GitLab itself, you can access it via the groups. It's in the Allotrope open source group. Then you'll find the Allotrope DevOps, and there's a wiki there. It's also linked from the repository in the README file. Okay, that's all from me. Thanks for listening.